calling someone out for performing premature abstraction. The argument often goes something along the lines of that it's premature because if you're abstracting, that means you have to solve a general problem that might be very difficult, when in fact you don't know that you need to solve the general problem, so instead you should just solve a specific problem. To make the case, I would like to tell you a short story of a system I was involved in many years ago. I've thought about this system time and time again afterwards, and I've sort of come to the following conclusion. So let me tell you what the system was. Or honestly, a tiny portion of the system. So the thing I was tasked to develop was a grid that displayed a number of images. Now, that's fairly trivial, but the problem, the crux, was that the number of images were arbitrary. And obviously one of the requirements was that the images should not distort. So you couldn't just stretch the images. Now, if you could stretch the images, the problem would be more trivial. But if you, of course you can stretch them, you have to scale them proportionally, not stretch them like you can't make them 200% wide and 100% in height. Now, there are of course general solutions to this problem, and they're not even that complicated. So the one I went with in the end was an idea where you split. Actually, after discussing with my father about this, we figured the easiest way to approach it is probably to split the image in half, split the canvas in half, and then split one of the halves in half, and then split the halves of the halves in half, and then keep doing this procedure until you have an equal number of halves in comparison to the number of images that you need to display. And that does work. However, of course, this took a longer time than if I would have simply said that actually we need a fixed number of images, or we are okay with the fact that an extra image causes the page to scroll, or if we decided upon whether the page would usually be viewed in landscape or in portrait. I didn't mention that when I was talking about the problems before, but one of the things that make the problem more complicated is of course that you also want to not have, say, 30 columns and 2 rows. Right? That doesn't really display very nicely, and that of course depends upon the resolution of the screen you're viewing it on, or rather the dimensions of the window. But let's not dwell on either the solution or this particular problem. The point is that there is a solution, but the solution took more time to find, or it took a longer time to find the solution that is more general than if we would have imposed some constraints on the requirements and instead solved the specific problem. So when people say that you're prematurely abstracting, a lot of the times you'll meet this argument. They'll say that you are trying to solve the general problem when in fact you should be solving the specific problem. Because, yagi, you ain't gonna need it. Right? You are not going to need the general solution. In this particular case, it was extremely evident because I, as a developer, spent a lot of time on this particular feature, right? You know how programmers really want to solve some problems that we're facing because it's sort of intrinsically interesting in itself. I found myself in one of these situations with this problem, so I really wanted to actually solve it. So again, oftentimes the argument is that you're trying to solve a general problem when in fact you should be solving a specific problem. Now, the point I want to make now is that you don't always have to solve the general problem, but you could still be creating abstraction. So abstraction in itself does not only mean solving the general problem that you might think is the general problem. It could potentially mean abstracting in such a way that you allow for yourself to change the specific implementation if your requirements change. Let me explain. So in this particular scenario, instead of trying to solve the display old images when all of the pieces are moving, or let's say without making any tough decisions, instead of trying to solve that general problem, I could have solved one of the specific problems, essentially, for example, choosing landscape or portrait. And I could have an implementation for that. I could have a different implementation for overflowing when you have an extra image more than you, or when you have, say, uneven quotation marks number of images. These are all specific solutions. And the point is that if you implement one of these specific solutions, but make sure that you abstract your code enough such that you will be able to exchange your specific solution for another specific solution. And if we're being more specific in this discussion, I should perhaps call it a specific algorithm rather than a specific solution. It's not about solving the mathematically tricky general solution. You could still solve just the specific solutions, but because you know that the specific solution might not be the right solution, might not be the solution that the customer wants, or be the solution that you'll want in the future, then you take heed for that. You say, okay, actually, we might need a different specific solution in the future. Or sorry, I should start saying algorithm. We might need a different specific algorithm in the future. So we'll create a seam in the system where it's possible to exchange one of the specific algorithms for another specific algorithm. Essentially, dependency injection. By the way, if you want to know more about dependency injection, I highly recommend you to check out my other video on dependency injection. So, using this kind of abstraction, I would strongly argue that this is not premature at all. This is completely sensible. This is expecting that you have understood a requirement incorrectly and creating a seam in your system where you, in the future, will be able to exchange the one specific piece for another specific piece that may take you closer towards correctly understanding that particular requirement. I'm running out of battery, so I'll have to wrap this up. But the point is, be careful when you accuse someone of prematurely abstracting. Just because someone is abstracting does not necessarily mean that they're spending time trying to solve the general problem. They could, in fact, be creating a seam that will make it possible for you to exchange one specific algorithm for another specific algorithm in the future. And I would argue that performing that or creating that kind of seam is almost effectively free. Of course, it's not free, but the cost of performing it is very, very low. In comparison to, of course, the cost of solving the general problem is, of course, not low. So the criticism of solving the general problem is, of course, warranted. So those are my 5 cents. Be sure to subscribe if you want more code talks like this, and I'll see you next time.
跟住呢，我是跟指出佢講係點解會換啊？加入到成件事嘛，跟住佢出過講咗。
If it quacks like a duck, it is a duck. This is one of these phrases people tend to throw out and then make everybody else confused. Let's talk about duck typing. So I can't give you the deep down depths of what it theoretically means. We'll talk about that in another video. But generally speaking, duck typing is about determining the suitability of an object based on what it does rather than what it is. To be even more specific, whether a method can be passed a specific object, i.e., whether the object is suitable as an argument for the method, is commonly, or in a non-dynamic language, determined by the type of the object, i.e. what type the object is of, i.e. what it is. But duck typing says, actually, what does it matter what it is? Let's instead determine whether the object is suitable or not based upon what it does, i.e. what methods it responds to. So in other words, if a method takes an object and then calls the method quack on that object, then as long as the object responds to the method quack, what does it matter whether it's a human or whether it's a duck? Right? The common example is a human pretending to be a duck but still responding to the quack method. An interesting parallel I find is to consider the Turing test. You know, the test for artificial intelligence. It seems to me that the test is about sidestepping the question of what is human, because it's philosophically difficult. So instead of attempting to answer the question of what is human and what is not, the question is sort of restated, where the experiment is designed in such a way that that question is ignored. So the Turing test seems to provoke the question of that if something behaves human, what does the question of whether it is human or not, what does that question matter? If it behaves human and we can't distinguish it from an actual human, then what is really the question of whether it's human or not? Now, this is of course almost a kind of far-fetched analogy, but really I find it quite suitable for duck typing. Because duck typing does the same thing. It says, what does it matter what something is? The thing that does matter is how you want to use that object. And if that particular object does in fact respond to all of the methods that you want to call upon it, what does it matter that it is not stated to be of the type that you expected it to be? So, very practically, what does this mean? This means that in dynamically typed languages, like Ruby or JavaScript or whatever, in these languages, you are not specifying the type of something. So when you're extracting a method, and the method takes an argument, you are not stating explicitly, you're not telling the compiler or the interpreter what that method is expecting, what that method is expecting in terms of the type of the argument. You're simply saying that it wants to receive something, and then you go about calling methods on that thing that it accepts. So that means that when you are receiving that concrete object as an argument, you are expecting it to behave according to some particular specification. Or put more lightly, you're expecting it to respond to a certain set of methods. So from a very pragmatic point of view, we could then say that duck typing is really nothing more than polymorphism without a hierarchy. So it's dynamic dispatch without an inheritance hierarchy, or without explicit interfaces. So in other words, in a statically typed language, such as C# or Java, I'm now ignoring the keyword dynamic, but basically in a statically typed language such as C# or Java, in order to achieve dynamic dispatch, i.e. call a method on an object whose type is not known at compile time, or I should say whose subtype is not known at compile time. Essentially, you have to either create a common ancestor or construct an interface. You have to somehow explicitly tell the compiler that you are expecting something that adheres to a specific specification, right? To a specific interface that responds to a certain set of methods, and then you can treat it as such. So, returning to a classical animal example, right? You would say your method takes something of type animal, and then you would have children that are subclasses of that parent class animal. So you could have lion and cat and dog, and consequently that means that the method that takes animals can also take lions or dogs or cats. But returning to the concept of duck typing. So duck typing says that it doesn't matter whether a lion is an animal, whether a cat is an animal. What matters is that it responds to the methods that we want it to respond to. So in dynamic languages, we can pass any object anywhere, and if the object does respond to the methods that you do want to call upon it, then that object does pass the duck test. In some sense, then, it is a duck because it per se did respond to the methods that make it a duck. So to push this one step further and think about the practical consequences of duck typing, people argue that you should not perform type checking. Type checking is in many senses considered a code smell. We'll talk about that in a separate video. But assuming that you buy that, that has interesting consequences for duck typing. So because in dynamic languages, you don't know what the type is of things that you are receiving. And it may be, at runtime, it may prove to be of any type. So how to make sure that you are not calling methods on, or that you are not calling quark, for example, when given something that is not a duck. So naively, we oftentimes resort to type checking. But the strong followers of duck typing, the way I understand it, would instead argue that you should not check for what something is, but you should check for what something is capable of doing, if you should check at all. But assuming that we need to determine whether we can perform some particular action on some particular object or not, then you should check for that capability, and you should not check for the type, knowing that that type does have that capability. To understand this, let's consider an analogy. If you're familiar with the concept of responsive web design, you've probably already come in contact with this concept of not trying to determine what something is, but instead focusing on what something is capable of doing. So in responsive web design, the idea is that there are so many devices out there. There are cell phones and tablets and computers and tons of different browsers and different versions, and like they're just accumulating as the years go by. So the point is that instead of trying to check in which particular environment your application is running, right? The argument is that that will bring you down a path of madness because there are just so many. So we're just going to have to create more conditionals and more conditionals and more conditionals and keep on checking for different types. So the argument is that you instead should be checking for capabilities. So instead instead of determining whether something is, whether the environment you are running in is an old browser, for example, because you have some knowledge about what that particular browser does or does not support. You should instead check for the capability of performing the thing that you actually want to perform, and then making a decision based on that. So, similarly for duck typing, instead of switching on a bunch of types that may or may not hit your application at that particular point of the code, you should instead switch on the things that you are actually aiming to use, if you are intending to switch at all. In order to nail this down one last time, the concept of duck typing is to not use information about what something is in order to determine suitability for a particular purpose, but rather to use capability as a way of determining whether it's suitable or not suitable for performing that particular purpose. So that's it about duck typing. If you find my explanation completely and utterly confusing, please do let me know and we'll dig further into this. And as usual, if you want more programming books like this, be sure to subscribe. So I did a previous video on why you should be wary of using the static keyword. Naturally, I'm amongst many others to have this opinion, but even though some people find it slightly controversial, and since then I've had a few discussions, it has come to my attention that some argue the need for, or the usefulness of static functions because they argue they move towards a functional style of programming. In other words, the argument is that static functions resemble functional programming. I think this is a fallacy, so let's talk about that. So the argument is that static functions are actually not like functional programming. Let's dig into this. Functional programming has many important concepts. Two of them are that functions are first-class citizens and that the functions are high-ordered, i.e. high-order functions. So, I'm not at all an expert, but the way I understand it, it seems to me that functions are first-class citizens and that functions are higher order are sort of two sides of the same coin. They're sort of the same thing. Higher-order functions is a mathematical concept, whereas functions being first-class citizen is a computer science concept. So concretely, functions as a first-class citizen essentially mean that you can create a variable and create a function, reference the function in the variable, and then pass the variable around. Higher-order functions, on the other hand, the mathematical side, very simply means that a function can take a function as an argument and or return a function as output from the function, or as a return from the function, essentially. Which is actually not strange at all. So if you think about the function map, right, where you have a collection and then you map a function over that collection, that's an example of taking a function as an argument. Conversely, if you think about the concept of partial application, if you think about curry, that's an example of returning a function. We won't dig into what these specifically mean, but essentially, if you're familiar with these are examples of taking a function and returning a function. So that's higher order functions. Now, returning back to the topic, the point I wanted to emphasize in the previous video where I argued that you should be wary of using the static keyword is that the problem of using static is that we are coupling to implementations and not to abstractions. Instead of painting this picture as a problem, let's paint this as an opportunity. What we want is that we want runtime substitutability, essentially dynamic dispatch. We want to be able to call methods without knowing which object the method decides. Writing flexible code becomes really tricky otherwise. So such a concept is easily supported if you're in a language where functions are first-class citizens or higher order, because you can construct functions that take functions, which essentially mean that you can exchange the function, i.e. the implementation, at runtime. Static functions, however, does not work this way. Static functions, generally, you can't pass around. So I would even go as far as to say that not only are static functions not like functional programming in style, but actually, I think they're less like functional programming than if you would do classic object orientation. Because in classic object orientation, you have polymorphism, you have interfaces. So if you think about it, if you construct an interface that only has one method, and then you have another method that takes something that implements the interface as an argument, then essentially that's like passing a function. Not really, but almost, right? Because then you have substitutability at runtime, right? You have polymorphism at runtime, which you don't have with static functions. So again, functional programming is fantastic, but the argument against static functions have nothing to do with functional programming. So whenever you find someone arguing that you should move towards static functions because it's more like functional programming, please give them this video. Because there are many good reasons to believe that they're actually not. I hope this helps straighten some things out. And if you want more programming talks like this, be sure to subscribe.
Và lần này mình sẽ cho mọi người một cái app tên là Grammarly. Đây là ứng dụng là Digital Writing.
Functional programming makes it way easier to have parallel execution. Essentially execute parts of your program in different machines or in different processes or in different threads. I want to briefly talk about why this works. Parallelizing. To understand why that is so, we first have to understand what a pure function is. So stated very simply, a pure function has two rules. The first one is that given the same argument, the function must always evaluate to, i.e. return the same result. So if you have a function that takes two arguments, and you give it, say, a 1 and a 2, you should always, at any point in time, if you give it those two values, you should always get the same value back. Rule number 2 is that it should not have side effects. A side effect is essentially state outside of the function itself. So in other words, this means that your function can, for example, write to disk or write to a database, which, as you might guess, of course, makes it very hard to write a usable program. But that's a topic for a whole nother video. So let's talk about that another time. So given that you have a function that follows these rules, you have a pure function. So the question is that if you have two functions that are pure, why is that easier to run in parallel than if you would have to impure functions? So the point essentially is this. If you have two impure functions, it's entirely possible that one of the functions depends on state that the other function also uses or depends on. Think about it this way. If you have a function that reads values from a file and another function that writes values to a file, then depending on which order you do these things in, you may have different results. It's entirely possible. But if the functions were pure, then they can't have side effects, which means they can't do things such as write the file, which means that you could take one thread, run one of the functions in, you could take another thread, run the other function in that, and thus you have parallel execution. So, of course, you can always run anything in parallel, but the point is that we have pure functions. You are certain that you don't have to state that you are mutating between the functions. To finish up with an example, think about this. You probably also heard about the concept of MapReduce. I don't want to get into the details of MapReduce, so we'll get into that in another video. But when you are performing MapReduce, you're essentially performing two separate actions. You're performing map and you're performing reduce. So map essentially means that you have a function and you run that function over a collection of inputs. You are taking the collection of inputs and for each item in the collection, you pass that as a value to the function. Right? You have a collection of the same length with all the processed outputs, or the processed inputs, i.e. the outputs. Then you pass those to a reducer that takes the multiple values and constructs a new value from these, which could be a short list or a single number or long list. So the interesting part about MapReduce is essentially that if your map function, if the function that you are running over the inputs, or with the inputs as arguments, I should say, say, if that function is pure, then that means you can parallelize the running of that function. You have, which is why mathematics obviously has become so popular. So you have a massive data set of millions of rows. It doesn't, of course it matters, but you can still get a very quick execution time because you can parallelize and run on multiple threads. Just compare that to running it in sequence, which would take massive amounts of time. So that's it. I hope you gain a further understanding of why functional programming, or more specifically, pure functions, help us run programs in parallel without running the risk of having one function mutate the state that another function depends on, which hypothetically or theoretically could cause erroneous outcomes. So that's it, and for stuff like this, be sure to subscribe. Single responsibility principle, which is standing for the S in the solid design phase, essentially states that a single module or class should be responsible for a single piece of the functionality of the system, which is only unity that it should do a single thing. But the question is then, of course, what is a single thing? Today I want to give you a short explanation which I find very useful, and which essentially is Robert C. Martin's explanation, also known as Uncle Bob. And essentially he rewrites the principle as such. He says that a class or module should have a single reason to change. And this wording is not massively different, but it's sort of nuanced. So he talks about having a single reason, right? A cause of having to change, instead of the idea that the class or module should do a single thing. So in that sense, Bob Martin talks about what happens to the class in the future, whereas the single responsibility is traditionally stated in terms of what it does currently. I will just borrow one of these examples because I think it's very useful in understanding how to sort of slice the pie what's considered a single thing. He gives an example along something like the following lines. Assume that you have a system, and then think about the different people that can come to your desk and ask you for changes that they want to impose on the system. So think about then what working goals people have. So if, for example, say it's kind of like an accounting system, it's a bookkeeping system online, right? So you might have a lot of financial reports. So a designer might come to you and ask you to redesign a particular piece of a form, right? So move this entry field here and move this label field here and change the color of this thing, and blah, 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 right? But a person from finance might ask you to add completely new things. For example, might ask you to add a new combination. Say that there's the law changes and now suddenly all reports need to include such a number. So thus they ask you to include that number. Right? There are overlap here, of course, right? In adding the number that the finance guy asks you for, of course, you have to also perform some design. But the point is that these are different reasons. It's entirely possible that you add the new finance calculation, you implement the change that the finance person is asking for, and the designer is completely happy about that, right? Because it's reason is very limited to the idea of goals and people coming and asking for changes. But if you're building your own, if you're running your own product, if you're a small startup, or if you for some reason don't actually interact with people who give you change requirements in such a manner, then of course you have to envision these incoming change requests to yourself. You have to say, how would we potentially want to change this in the future? We talk about startups, for example, the concept of pivoting, right? So then you can think, how would we potentially want to pivot in the future? If the idea is, for example, we're currently doing this, but potentially we could be doing that, right? That would be a reason to change. Changing from the first thing to the second thing would be a reason to change. So that change needs to be isolated somewhere. But let's generalize a bit. I'm not saying that you always have to think about work roles when considering whether you're adhering to the civic responsibility principle or not. But I find that the wording a single reason to change extraordinarily helpful. So think about it from this perspective. Another way to sort of slice the pie would be to say that when something happens in your system, or the order of how things happen, or why something happens, is not necessarily the same thing as how that particular thing happens. Right? So why, when something happens, it's not necessarily the same thing as what the thing is that happens. So in terms of change, that would mean that it's not necessarily so that the order of the event changes at the same time as the contents of the events. Right? I myself am currently working on simulations. So the order in which certain events happen in the computer simulation change independent of how they actually happen. Right? So assume we're simulating ecology and we have a bunch of animals and put them into some natural habitat, and then the animals perform different things such as eating and sleeping and drinking and hunting and whatever. So the order in which we simulate these events could change independently of what those events actually constitute. So I'm pushing this sample, but the point is that has nothing to do with roles, right? Working roles as in a company, but it has everything to do with having different reasons to change. We might, given our domain that we're in, right? Given the things that we're doing, the things that we're modeling, it's entirely plausible that we would want to change the order of things without changing the content of the actual thing, and vice versa. So that's all I wanted to say about Bob Martin's explanation of the civic responsibility principle. I'll link some of his videos in the description, so you can check that out. And if you have other good explanations or ways to think about the civic responsibility principle, I still have it here, so shoot me a comment, and I would love to do another video on that particular way of looking at the civic responsibility principle. That's it today. Thanks for watching, and subscribe to all.
所以跟住我哋都要sử dụng結果咧，原來佢每人單個寫車成萬跟住佢速度改開半年。
So unit testing versus integration testing. What do people mean when they say integration testing? What do people mean when they say unit testing? There are many ambiguous definitions such as a unit testing is something that tests a single unit of work. But again, highly ambiguous. What does a unit of work mean? Let's talk about that. A unit test is isolated test. Integration test, on the contrary, is an integrating test. So unit testing is when you're testing in full isolation, not half isolation, but fully isolation. And anything that's not completely isolated, by definition, is an integration test because it's not a unit test. So we now have to define what we mean with integrating. A simplified view would be to say that if component, module, class, whatever, uses any other module, component, class, then it's integrated. But that would also, of course, encompass integrations with the language or the framework that you're using. When I say framework, I use the term very loosely, because I mean framework or library or language or essentially anything. So if you're in Ruby, it's Ruby core. If you're in .NET, it's .NET, etc. So essentially the core of the language that you're currently using. So if you're using fine mutations or random or even string helpers such as line regexes, or you have an instance of a string and you say .substring, or you use string interpolation, so formatting or things like this. That would mean that you're integrating with something else. And if you take that extreme in absolute, you'll realize that it's very hard to isolate anything if you can't integrate with anything that's given by the language that you're in. So I would take a little bit, a tiny step back from that. Let me give you what I consider to be a fairly ambiguous definition. So I would consider it like so. I would say that the main framework is non-deterministic. than integration. If it's deterministic in the main framework, I would say that your test is still a unit test. And whenever you are using any piece of code that's not your own, and that's not in the core of the language you're in, or the sort of main framework that you're in, then that makes your test an integration test. However, any code that you write, if your class uses another class, that's necessary integration always. Doesn't matter if it's deterministic or non-deterministic or anything else. Nothing matters. As long as your class or module uses other class or module that you wrote, that's necessary integration. Okay, so that's my quick definition of the difference between a unit test and an integration test. I'm pretty sure you were aware that a lot of people are arguing you should reduce the number of integration tests and have fully isolated unit tests. But if you think about the definition I've just posed, you will realize that it's kind of tough to isolate fully and turn your integration tests into unit tests. I would subjectively argue that it's worth it, and I won't go in this video into how to actually isolate your integration tests, but I can very shortly say that the solution is dependency injection. So if you want to know more about that, do subscribe to this channel. Dependency injection, dependency inversion, constructor injection, parameter injection. What does it all mean? Why do we need it? And how do we actually use them? Constructor injection, I find, is one of these things where when you first understand it, you think it's absolutely trivial because you're like, well, I've been injecting values or references through my constructor since like day one. So how is this anything but trivial? But when you then really understand constructor injection, i.e. dependency injection, through the constructor, you realize that it's massively powerful. You realize that it's not at all the same thing as just casually passing values through the constructor. There's much more nuance to it than that. So let's first get the concept straight. Dependency inversion is the all-encompassing principle. It states that you should invert the dependencies. So you invert the relationship in a way that might seem unnatural. Dependency injection is the specific act of inverting the dependency. Constructor injection is when you're performing dependency injection through the constructor of an object. And parameter injection is when you're performing dependency injection through the parameter of any function of an object. So stated in the most simple sense I can think of, instead of considering the formal definition, I would think of it this way. Dependency injection is about never coupling to a concretion, always coupling to an abstraction, right? Obviously that's an oversimplification because at some point you have to create a concretion, but we'll return to that in the end. So the point of performing dependency injection is that you want to be able to change your instances of classes at runtime and not only at compile time, which essentially means you can change behavior of your program at runtime and not only at compile time. And which also means that even at compile time you can change the behavior of the program without rewriting classes, but instead by writing new classes and then injecting those members instead of rewriting the old ones. So dependency inversion increases the flexibility of our code. It increases reuse, right? It encourages small classes with limited responsibilities, and it makes it easy to exchange one instance for another instance in order to change particular behaviors. That's one of the aspects. The second aspect is testability. Without dependency inversion, testability or unit testing, isolated unit testing would be really tricky. Because when you want to test in isolation, you want to test a class without integrating with other classes. So in that case, instead of allowing your class to integrate with other classes or allowing your object to interact with other objects, you inject a lock that you have full control of. So you use dependency injection, which is possible because you have used, because you are designed according to dependency inversion, and inject a class or an object that you have full control over, which means that you can A, test in complete isolation, and B, because of that, avoid unwanted things such as random numbers in your test, for example. Just imagine if your test would pass 50% of the time and fail 50% of the time. Obviously, you want to avoid that. How do we actually do with dependency injection? So I'll only talk about constructor injection because I think when you see how constructor injection works, you'll trivially figure out how parameter injection works. So imagine that you have a class called animal. And imagine that you have a bunch of animals inheriting from that class. So we have cat, we have dog, we have cow, etc. Imagine then that these classes have an instance method called speak. And this instance method doesn't really matter what it does, but let's say it prints in strings. So the cow says moo and the cat says meow and etc. So naively, we might hard code this behavior of either saying meow or saying moo into the speak method, into the specific class, i.e. moo would be in the cow class and meow would be in the cat class, etc. This is sort of object orientation 101, right? This is what you learn in class. Of course, in a bigger system, if it's not about saying moo, it's rather about something very complex. So soon, essentially, is much more code. So then you might think, okay, let me put this behavior in another class. So perhaps you have cow speaking behavior, don't speak, and you have cat speaking behavior, don't speak, and so forth. We now have two hierarchies. We have animals and we have speaking behaviors. Okay, so this is all fine and dandy, but the problem is that we are potentially breaking dependency inversion. Let me explain. So if the cat instantiates the cat speaking behavior and the dog instantiates the dog speaking behavior and so forth for the cow, then we are breaking the dependency inversion principle. Because the high-level module, i.e. the cat, the dog, the cow, is coupled with a low-level module. In this case, the speaking modules. So dependency inversion says actually you should invert these dependencies such that both the high-level module and the low-level module should both depend on abstractions. The abstractions in this case are the parent classes. So for both of these hierarchies, the parent class for the animal and the parent class, i.e. speaking behaviors. Not the concrete speaking behaviors, nor the concrete animals. So the dependency inversion principle in this case essentially states that animals should not be coupled to concrete types of speaking behavior, but rather to the abstraction. So this means that we want the animal classes to not instantiate their own speaking behaviors, but rather that they somehow should receive a speaking behavior and then run the method speak on that speaking behavior. How they would receive that would be through either constructor injection or through parameter injection. And the point here is that the concrete animal class, i.e. cat, or etc., then only knows about the abstract or the abstraction speaking behavior, and it doesn't know about concrete speaking behaviors such as the cat speaking behavior and the cow speaking behavior, etc. The most interesting point, or the most interesting benefit about this design, I find, is that oftentimes you realize that actually you don't need subtypes. Actually, in many cases, dependency injection is enough, and you don't need inheritance hierarchies, which is probably what people are saying composition over inheritance, right? Because you can compose what behaves as your subtype instead of actually constructing your subtype. In this particular case, assuming animals do nothing else, then cat and dog and cow would all contain the same code. They just have different names, which makes them completely redundant. So in that case, we only need animal. Thus, this is how we've achieved composition over inheritance, because we only have one animal class, and when we want to construct a cat, when we instantiate a cat-speaking behavior and provide it to the animal class, and thus the animal instance will behave as a cat. And similarly for cow and for dog. So if you take dependency injection sort of to its extreme in absolute, then you will realize that you can always inject dependencies instead of instantiate them. You should think about this also why people say that the new keyword is dangerous. You should always be wary when you see the new keyword. Is this really the correct case to couple to a concretion instead of an abstraction? So using dependency injection, you can always defer using the new keyword. You can always defer instantiating upwards, backwards, out of the system, right, towards the main of your program. And this is actually what happens if you use dependency injection into madness, right? In some sense, you could instantiate all the players in the main of your system and then have no new keywords in the rest of your system. But of course, there are always trade-offs, and I would actually say that a little bit of dependency injection is better than no dependency injection. A little bit of inversion is better than no inversion, which you'll discover when you, for example, try to test your units in isolation, or when you try to quickly respond to new requirements without constantly having to change all of the code. So that's dependency injection. Please ask any sort of questions that you might have in the comments, and subscribe for more. Today, I want to entertain the idea that abstraction in object-oriented programming always equals pragmatism from an economical perspective. So usually the argument goes something like this. Because we've got a long backlog of features, we need to ship fast. We can't work with abstraction, can't work with refactoring, because we have features shipped. Another common perspective is startup, right? Startups that are figuring out what product they're building. So the assumption for this discussion is that you think that lean is a good idea, that you embrace the idea of pivoting fast, pivoting quickly. Or you can see from agile perspective, release early, release often, right? So build your product as soon as possible so you can get it out there, get it in front of customers give you feedback, and you can iterate and try again, right? Pivoting kind of makes sense, right? How could you know exactly what your customers want? You might be thinking about it in incorrect terms. And instead of sort of silently pondering that for ages and ages, you just get it out in front of the customer and together figure that out. So the assumption of this discussion is that you think that that's a good idea. But this video is not about me, nor about pivoting. My argument essentially is this. It seems that if you want to pivot, you're expecting to have to pivot. That means you're expecting massive change. And in object-oriented programming, whenever you're expecting massive change, you need abstraction. To be kind of crude, you could, for example, say that I'm oversimplifying, but with the concept of dependency injection, the whole idea is that you can defer. You need something that implements a particular interface, but you don't necessarily care what it is, or rather, you don't necessarily know what it is at this moment, which means that you want to defer. My battery died, and I'm not sure if it was because of the cold or because I just generally never charge it. But let's continue. What I'm saying is this. It's kind of like the general consensus is, in order to go fast, I have to write bad code. And with bad, in this case, I mean code that you would somehow later probably want to refactor. But you choose not to refactor now because you just want to move fast. So I guess the argument is something like this. Specific code is faster to write than general code. You're figuring out abstractions is difficult. And fair enough. I mean, that makes sense, right? Solving a specific problem in programming is, a lot of the time, easier than trying to solve general problems. So from a business standpoint, and from a business point of view, from a startup point of view, when I have a client and I need to roll out features, for all of these scenarios, it kind of makes sense to say, well, let's not worry about the general stuff. Let's just focus on solving these specific issues as quickly as possible. Here's the problem. I think it's true that solving the general problem is more difficult than solving the specific problem. I agree with it, but I don't think that's where the problem lies. The problem is this, that solving the specific problem is easier if you know what the specific problem is. But I would argue that in software, and I don't think this is a particularly controversial thing,
software more often than not don't actually know what the specific problem we're solving is. I'm not going to talk about where you upfront know exactly what to do. Right? I mean, if you're implementing a sorting algorithm, for example, right? You might actually know exactly what that algorithm does. But for software that has clients, where it's ambiguous, where the user requirements might change over time, I mean that usually we know roughly what we want, what they want, but we don't know exactly. The point is that because we don't know exactly what application we're doing, the smartest thing we can do from an economic point of view is to stay flexible. So what I'm saying is, forget about software for a minute. Just think about if you're launching a startup, right? Assume you're in this stage where, okay, I actually want to develop this product. I'm not really sure exactly what the product is because you can't be 100% sure, 100% accurate on how you're actually supposed to do it. The point is that you should then defer as much as possible. Then you inject and you might say, oh, but okay, that's again the whole thing about when you're building slowly, when you're building really rigid applications, really an application when you're refactoring into something great. Right? But now just need something quick and great. My argument is no quick and great. Think about it this way. When you pivot, what would you rather do? Would you rather say, well, I'll take this whole application and I'll just throw it out in double and I'll restart from scratch? Or would you say, I'll take this tiny bit of the application, throw it out the window, write a new piece for that part of the application, and dependency inject that piece instead? I consciously said to throw out, not to rewrite. I consciously said dependency inject, right? Because open close principle, what I'm saying is that to maximize the chance of being able to reuse code in your pivot, you should clearly decouple your system, consciously decouple your system. So what I'm saying is that abstraction doesn't mean that you have to solve all of the particular problems. It just means that you need an architecture that doesn't say, oh my god, I need to rewrite the whole application, I need to throw out everything and start from scratch whenever you discover a new requirement. And I'm not talking, this is not the software developer perspective. This is not the perspective of a guy saying, oh, source code must be clean because source code wants to be clean. It's not la pour la. And it's not arts for art's sake. It's not code for code's sake. This is a business point of view. This is saying if you want to be economical, if you want to be able to pivot with as low cost as possible, then you need to build flexible architecture. Then you need to, at every step you take, you need to say, okay, well, in case we need to pivot. Right? I'm not saying in case we need to change things that are stupid. Don't change. Don't anticipate stupid change. Be smart about the things in this way. You say, okay, potentially could deliver more value if we would take this path instead. So then you anticipate that change. That doesn't mean that you solve that specific problem of right? But you abstract just enough so that, let's put it this way, there's a scene in your system where if that happens, if you get to the point where you want to change that particular thing, you have a logical place in your system to throw out the other one and build a new one. So what I'm saying is that when you're breaking design principles, you're spending time building yourself into a corner that you can't get out of without throwing out massive pieces of the application and rebuilding from scratch. And the open-close principle says that you can, if you actively try to find the right seams in your application, then you don't have to throw out massive pieces of your application. You can just throw out smaller parts of your application because you inject the members that do the work. You just figure out what the seams are between all of these different pieces. So let me wrap up before I go off topic. The point is just this. When putting abstraction versus, when saying abstraction versus pragmatism, my answer is that it's not a continuum. They're not on the same scale. In object-oriented programming, to abstract is to be pragmatic because it's saying, I probably don't know what solution I will need, how this works, how I will deliver value to my customer. So I need to build for the opportunity to change my mind. When it comes to performance, I totally buy the argument that performance you should worry about later. because performance generally messes up abstraction, generally messes up good architecture, right? Because performance goes towards the specific. Performance says, figure out exactly what we need to do. Let's do that thing brilliant, superbly good. So this is why you can say performance versus practice. And I completely bias argument because performance you do later. Just build your feature and make sure that that's the right feature and then optimize it. But that argument does not hold for design. The whole ideal design, the whole ideal architecture is to build your applications in a flexible way so that you can change your mind later. So you can say, actually we have a bunch of customers who want this, let's pivot towards that. Right? Or, oh my god, we built this completely wrong and nobody likes this and we move in this direction, pivot into that direction. Or competitors start to pop up and they do something you don't do and you figure, oh my god, we have sort of the same problem but they're solving it that way. Pivot towards their solution. That's flexible architecture. So I said I would wrap up and then I didn't wrap up, so let's now actually wrap up. If you think I'm totally crazy and that this is idiotic, please do he has a comment. But also it has a lot of in software where you have the ability to pivot very quickly. You should work together with business and whenever new business requirements come in, pivot quickly towards them because you have that opportunity and you have a good architecture. And it starts from day one. Creativity starts from day one. This is not something you can invent. This is not something you can figure apart. You never figure it out. Like business is just constant pivot, constantly trying to reshape your products to fit the demands of your customers. Right? Because evolution, right? Survival of the one who can most perfectly meet customer demands. And customer demands must stand. Customer demand change. Customer demand change. Let me know what you think. Feel free to leave back in the comments. Thanks for having this chat with me. And I'll see you next time. Alright, today I want to talk about why you should never, ever, ever, ever use the static word. I just got myself one of these so I can mount a camera and make some videos while being in the car. No asking. Okay, so now I'm just carrying it, so we can do that. Lean! Whoa, that's so cool. Sweet. Alright, so when people say never, usually they mean hardly ever. But I mean, I think a better practice is just say never use static than hardly ever. Because if you go by hardly ever, I think we're going to use it too much. So here's the reason why. Before I go on a rant on why you shouldn't use it, I think it's okay to use static if your project is a toy project. Like code bases that you would never share with anybody else, right? Code that nobody would ever have to read and understand and maintain. I think the keyword here is actually maintain. Having that said, let's talk about the other cases. So there are two reasons. Now we'll talk about them as if they were two, but they're actually very correlated. But it's easier to think of them as two graphs. So one is the concept of change, and the other one is the concept of global. So global scope and global state. But let's start with the first. There's a quote. I can't actually remember who said this, but check out the description. I'll link to whoever said this. But there's a guy who said that one man's constant is another man's variable. That's just spot on, right? Everything is relative. Don't fool yourself into thinking that you know what the world looks like. Don't be a fool, right? What you think is a constant someday might turn out to be, or turn out to have to be a variable. Or for another user, it might have to be a variable. And the important part here is to note that another user naturally doesn't mean end user. That means whoever is using the thing that you
you made static. So if you have a class, and that class has a method, and you made the method static, then the person we're talking about here is the person who uses your static method. So you might think that it was okay to make it static because you thought it was a constant. Now we're using the word constant in a sort of very liberal sense. Because you thought it was constant, but for that person, it might need a variable. So that's one of the aspects. The other aspect is global. There's another great talk about, I can't remember the name of that guy either, but there's another great talk, I think it's called like the Clean Code Talks. It was a series a while ago at Woo. So I'll link that in the description as well. But he talks about how singleton pattern is just an excuse for working with globals. It's just globals, it's nothing else. And I want to make the case that statics are globals. So think about the word global. I mean, we all know that globals are bad, but why are globals actually bad? We have global scope and we have global state. The global scope means access, right? You can access it from anywhere, right? That's bad because, in a very vague sense, because you run out of sensible variables, right? You probably naturally scope your variable by name so that you could make sense of it, right? Like player underscore help underscore max. But more importantly, the second point in terms of globals is state. Much more dangerous. Global state. If you're in an instance method and you read or write to global state, that means that some things may have some values that you are not in control of. I've got that here to check out the car today, and I just went to get some oil cleaned out from under the hood. Right, but now, so that's done. Moving on to the next. Let's get the car washed. So let's not dwell on why we shouldn't use globals, because I'm pretty sure you already agree that globals are bad. I mean, there are a multitude of reasons. For example, that your systems are harder to reason about because your components would be harder to reason about, because your component depends on state outside of themselves, which means that the component could behave differently depending on in which context you ran it. And that it might not be that particular component that has inflicted the state that it depends on. It could be another component. Right? Anyways, given that we agree that globals are bad, I would think that you, after thinking a bit about it, or perhaps this was your opinion before, you agree that statics are actually just globals, right? Because statics are just namespace globals. What do I mean? I mean statics are global state, but not global scope, right? As in namespace, as in that term, as in I should rather perhaps say global namespace. They're not in the global namespace, but they have global state. Okay, let's dig into this. What do you use static for? Oh, two common suggestions. You have a class and you create instances of it, and you want to keep track of how many instances, or a list of the instances, or something like this. And then it's very convenient to just put that as a static method on the class. So you would have player, and the player class, whenever you instantiate a new player, you add that player to the static array in the player class, right? And this is super common. I mean, Rails, for those of you who work with Ruby on Rails, you have a lot of user-specific functions on the class. You have static functions on the class to reason about instances. So you have user.find, capital U, user.find, to find instances of users, which means that somewhere there's some kind of manager of users that's accessible via this global state accessor, right? So the other very common way that people use static is to do like utility kind of stuff, right? Like math.random or any kind of math function. Or like, like say string manipulation, for example. So you would have like, let's say you want to do some crazy regexes, right? And instead of putting that in an instance of something, you just make a utility class where you pass in strings and get back the parse strings and or pieces of that string in whatever. Utility functions. Or also commonly called helpers. Right? These often do not actually have states. I mean, random does have states, of course, not because, there's no such thing as random in the computing world, so we have pseudo-random numbers which easily use state to generate what seems to be random numbers. But a lot of these utility functions don't necessarily have states, right? So when I say, yeah, but static means that you have a global state, you might interject and say, yeah, when I use static, I never use state. I never use state. Okay, fair enough. And that's why I said this is a two-piece argument. That's why I said there's the global state part, but there's also the change part. If you have any reason to believe that something might change in the future, don't use static. If you have any reason to believe it, right, whatsoever. It's very simple. You've read Refactoring by Martin Fowler, or I mean, regardless, I'm pretty sure you're well aware of the concept. Because of replace conditional with polymorphism. Common refactoring has been given a name by Martin Fowler, right? Conditionals breed, in the words of Sandy Mans, conditionals breed. Conditionals increase the psychomatic complexity of your source code. It makes it hard to reason about it because you have all these branches of things that could happen and you have to handle all these different cases. But that's, again, that's a totally different topic. We'll talk about it sometime else. But assuming that you buy into the concept that it's good to reduce the number of switches, it's good to reduce the number of conditions, then you should want to use the concept of replacing polymorphism. Replacing conditionals with polymorphism. But you can't do that if you make your methods, if you make your members static. You can't replace them with polymorphism if you make them static. Then they're static, right? If you think about it, how do you use something that is static in your source code? If you want to say, let's talk about Rails. If you want to say user.find, if you want to find a user, you say user the class user.find. When you get serious about software design, you'll get into contact with the saying that the new keyword is dangerous. So I'll stop here to wash the car, but let's just finish this line of thought before we get done. So, why is the new keyword dangerous? It's dangerous for the same reason. It's dangerous because when we say, let's say something more specific. Let's say we have cats. We should say cat.new, right? In Rails or in Ruby or whatever it's new cat, right? You instantiate a cat. When you type in the word cat, coupled the thing that you're typing in, the class that you're typing in, you couple that to text, which means that you can't change your mind later. What if you said, actually there are two kinds of cats. In this particular scenario, I want to use a different kind of cat. I want to inherit the cat and make it specialized in some way, and then use that one. You can't do that because you have a concrete cat. So this is when you really start to understand dependency injection. Right? The new keyword is dangerous because if you instead use dependency injection, you can change your mind later. You can just say, I want something that corresponds to this particular API, that behaves in this particular way, that type. Right? Now we're getting into some serious object-oriented programming, some serious OOP. You shouldn't care about what it is, right? There's tons of concepts that support this, right? We can say you should program to interfaces and not to implementations. That's one. Right? There's good architecture is to maximize the number of decisions not made, right? And by dependency injecting, you can defer the decision because you just care about the API of the thing that you want. You don't necessarily care about the concrete type, right? So, trying to back, where was I? And when you understand that the new keyword is dangerous, it's very easy to understand that calling a static method or a static variable, accessing a static method or a static variable, is equally dangerous because you type in the name. Much like you type in new cat, right? In the same way, do you type in user.find, which means that later on you can't change your mind. You can't say,
actually, I would want domain object.find, or I would want entity.find, or record.find, right? You can't change your mind. Obviously you can always change your mind by rewriting source code, but you can't change your mind dynamically, which is the point here. You can't change your mind runtime. You can't change your mind. Think about this: the open close principle. You should be open for extension. You should be open for extension, but closed for modification. You can't support the open close principle if you use statics. How could you? In order to change what the static does, what the static thing that you use, to change what that does, you need to change the source code. There's no way of dynamically overriding it. There's no way of runtime changing. You have to rewrite. Okay, rant over. Let's get the car washed and then let's talk about testing. Wash it. Alright, did some shopping? Gotta get the vitamins.
The weather was shitty, but it's turning even shittier. Let's talk about testing then, right? Let me be kind of brief and just emphasize how this affects testing. Whoa. If you ever delved into the land of unit testing, you're probably aware that you can actually unit test in isolation. And it's just a matter of writing better source code. If you write source code that's decoupled, you can test components in isolation. If you write shitty code, you can't test in isolation. Everything is an integration test because all of your components are totally hard coupled to other components of your system. But if you decouple properly, you can test in isolation. The point is, with statics, you can't test in isolation. It's possible that in some scenarios, of course, it would be possible, but you can't be sure, and that's the point. We're using static methods, right? Essentially, you make a hard connection between the user and the used object, right? Or the used class or method or whatever. So you have some component under test, right? You have something you want to test. You want to unit test a class, say, and in that class you have a method, and you want to unit test that method, and that method integrates with another static method, such as, for example, user.find. I mean, capital U user.find. Then you're doing an integration test, right? Now that's fine. You would want that integration. But if you're doing a unit test, you don't want to call user.find, right? It might be, let's make an example. I mean, it might be that user.find makes a database call, right? And if you're doing a unit test, you don't want to integrate with the database. You just want to test that particular method. I'm not saying you have to, okay? But I talked about the guy who did the talks at Google before. He did a bunch of dependency injection talks. He puts it very, very nicely. At least you have choice. If you don't use static, right? But he's talking about singleton. But if you don't use static methods, at least you're giving the other thing using your thing, right? The other class using your class, at least you give that the choice of not integrating with that particular thing. So if it's user.find, if the find method lives on a repository which is an instance, right? Then because of open close principle, and if you use dependency injection properly, then the person writing the test can inject a mock, right? Without any sort of strange kind of wiring, just plain old constructor injection, right? You inject a mock, and then you can test the user class in isolation. But if you have statics, if you have user.find static, you can't test that in isolation, right? No matter what you do, you will call user.find, right? You will need some serious plumbing in order to be able to test it in isolation. The guy next to me thinks I'm crazy because I'm talking to a camera in the car. I'm not sure he sees the camera. In that case, I'm just crazy. So, let's wrap up here. I don't think these are particularly controversial statements. So let me know what you think. Please leave comments if you agree or disagree, or any kinds of other thoughts. So thanks for having this chat, and I'll see you next time. Cheerio. Wish me good luck with all. Success. Advance.
as well. Like they make three sizes of these tripods with three legs. One of them is tiny, one is sort of medium sized, and one is large. Don't buy the tiny one, it's totally useless, it's so small. But I'll link the other ones in the description because they're totally awesome. Side note.
So I forgot to bring a microphone, but I put my headset on my ear like this. So hopefully that will help to not make the microphone punch against my jacket. But we'll see if that works out, and I'll remember to bring a microphone next time. Anyways, I want to talk about design patterns, design principles, and I guess just software design versus the usage of frameworks or libraries. The point, in short, essentially being this: I think we're too quick to. By the way, check out Frank. Awesome. So I think we're too quick to reach for frameworks and libraries when in fact we should design that ourselves. By the way, here's it this way. I think it was Robert Martin, also known as Uncle Bob, right? I think it was him, I'm sure. He said something along these lines. Good design is to maximize the number of decisions not made. I think there's something very fundamentally smart about that point. Right? There's a lot to that comment. Essentially what it means is that whenever you are choosing some, for example, framework over another, or essentially when you're choosing a framework, what you're doing is you're coupling to that framework. Right? You choose a framework, and then you design some piece of your software to adhere to the specification of API of that particular framework. The problem is not that the framework could have, hypothetically, a bad design, a poorly designed API. The problem is that per definition, coupled to the design of the framework. If you think about it, it's actually quite surprising that we're doing these kinds of things. I mean, programming 101 is coupling is bad, cohesion is good, right? That's like the fundamentals. And why? I mean, think of it this way. If you think about economics, there's a concept of opportunity cost, right? Like, things don't just have a cost. The cost of something is also the cost of not choosing something else, right? The lost opportunity, which is why it's called opportunity, right? The same thing applies to software, right? It's the cost of not being able to choose the other thing without incurring more cost in terms of time, right? You can change your mind, you can choose the other framework later on, but then you're going to have to pay in terms of time, right? You're going to have to redevelop your application to adhere to that specification of that particular software, right? And then like the spontaneous reaction to this might be, yeah, but okay, adapter pattern and facade pattern and proxies and things like this, right? Like we have middleware software that helps us not couple tightly to the framework we've chosen because we couple to our adapters and then rewrite our adapters if we change the framework. And to some extent, I completely agree with this. Now that's perfectly fine. And this is, I agree, the way we should do it. This is the way we should use frameworks. And we should have adapters between them. I mean, let's be more general. This is the way we should interact with any external piece of software interpreted in our own software. Right? So whenever we're breaking the boundaries of our system, that particular breakage of the boundary should be well defined so that it's, the word I was looking for here is isolation. I should have said that it's well isolated. Dense in one place, not spread out all over the application. Point being that we're trying to avoid things such as shotgun surgery, right? Meaning that if you spread out the copy
and then you change the things you're coupled to, then you have to perform shotgun surgery, right? Not things like this. So I'm getting slightly sidetracked here. Let's get back to the point. What is it? Choosing a framework, by definition, means that you couple to that framework, right? Now, you can choose to couple more or less. Again, adaptive patterns, etc. But by definition, you couple. Okay. And we know that coupling is not a good strategy. High coupling is not a good strategy for good cycling. So let's be more specific. I'm currently in a project where we recently had a discussion about tree structures, the data structure of the tree. Right? In this particular project, we had a discussion around whether we should use some library or framework, or, I mean, those are probably too big, words that are too big for this particular scenario, but we were discussing whether we should use somebody else's code when managing the tree structure. Essentially, my view on this is like so. A tree structure is not necessarily a particularly complex data structure. Right? We as programmers should manage tree structures. Right? And if you disagree about that, if you think that there are details that are complex enough to motivate the fact that instead of rolling your own tree structure, you should use some other tree structure, then we're sort of getting to the heart of the point that I want to convey. Let me make another analogy. Sandy Metz makes a great point, and it's in a completely different area. He makes the point that there's like some of these things that are almost hardwired into us as programmers very early on when we learn programming. And what she talks about is essentially the idea of don't repeat yourself. So I think she makes a very good argument. The point is that the concept of not repeating yourself is so simple that we can take it to heart. The problem with that is like the same as with all rules, correct, but it's not always true. The point of don't repeat yourself is that we should not repeat things. Okay, now I'm being oversimple, but as far as it's about not repeating things that have a reason to change. In the same way as database anomalies, right? You should not duplicate the user's name over multiple rows because the user's name might change. And if you then intend to change it in all places, but forget to change it in one, then you have a serious anomaly. I think the heart of don't repeat yourself is the same problem, right? You want to avoid anomalies. It's not that we're intrinsically lazy. So I would like to suggest that another one of these things that we, as programmers, very early on, bring very close to heart and keep and safety in our hearts, right, is the notion of not reinventing the wheel. Right? And my point here is that it's sometimes good to reinvent the wheel because this is also a rule that's not always true. Right? And again, this is one of these very easy things that it's so easy and it sort of intuitively makes sense. Take it very close to heart. Keep it very close to heart. The notion of not reinventing the wheel, right? In terms of tree structure, the data structure, then it makes perfect sense, right? The concept of a tree is well known and well defined, and people have built these before, so we should just use them. Right? Or, and that logically sort of makes sense. And sort of, that's how we think sometimes when we motivate the fact that we should reuse somebody else's code, that we should reuse a framework, right? Like, why would I want to do routing? Somebody else, there's intrinsic details about writing routing that are difficult, and somebody else has found these, isolated these issues and sort of solved the problem. So why should I solve it? Why should I reinvent the wheel, right? So, I'm not saying we should reinvent the wheel all the time. Again, what I'm saying is that sometimes we should value decoupling over not reinventing the wheel. Right? So we should choose the right or wrong code with the purpose of decoupling, with the purpose of not coupling to somebody else's code. Right? We should consider that more important than gaining the luxury of not reinventing the wheel, of not implementing code that somebody else has already built. But there's always this valuation, and you always have to look at your particular scenario and consider whether it's one way or the other. There's so much I can. Again, all I'm saying is I want to nuance the discussion a bit. I want to say just because somebody else has written something which is very similar to your problem does not mean that you should grab that and put that in your source code. Right? There's a very high risk that will be that will increase the coupling of your source code, which runs a risk of making it difficult for you to change in the future. So let me make one final point before I wrap up. In the same project as I discussed before, so we're currently in the process of rewriting the sort of data layer for that project. And we've been in discussions back and forth about whether we should use a framework or a library or not. We've reused some existing code. And honestly, of course, I've been a proponent of using frameworks many times in these discussions. Right? Because, again, why reinvent a wheel if somebody has already successfully figured out the tricky details for you? However, we're very close to finishing this custom data layer up, right? Because we in the end decided to roll our own. And having figured out the sort of difficult details about this particular kind of data layer, I've of course been thinking back and forth about how to open source. Here's my take on it. I think that perhaps this is the kind of thing that should not be open source. Because the problems that we're solving cannot be put into a framework. The problems that they can be put in a framework, but I would argue that they shouldn't be put in a framework. Because problems that we're solving are essentially design issues where the design should be communicated rather than that the framework should be shipped. So what do I mean by that? I mean that what we're figuring out with this particular custom data is a way of sort of slicing the pie such that change requests are easier to handle. Or let me put it another way. It's a way of dividing up the pieces of a data layer such that allows you some particular kind of flexibility, right? That makes you ready for some kind of change. Right? So in that sense, it's a convention. Or in other words, it's a design. It's a pattern. Right? It's not a principle, but perhaps it's a pattern. Right? It's a pattern of what particular pieces of your application should be performing what, and how they should be interrelated, how they should be coupled. Right? I'll model a suggestion as to how they should be coupled. Because if you think about it, you think about the old Daniel pattern, right? The iterator pattern, and visitor pattern, factory pattern, etc., strategy, whatever. These are not frameworks, right? Because they're not suitable as frameworks. Right? They are a way of structuring your code. Right? And if you think about that, you can think about it different. Like, in some sort of vague sense, your data structure, right? But you design your classes in a certain way, not like a tree structure. A tree data structure is also about constructing a bunch of classes, right? Conforming to some hypothetical API. Right? So yeah, let's cut off here. I think the takeaway from this is I think we should reconsider, well that's too extreme I say, but I think we should be a little bit more careful or considering or strategic before take framework. For the next time you feel the need to reuse somebody else's code when in fact it would be potentially feasible to write it ourselves. Again, with the argument that cost of rewriting that particular piece of software yourself is lower than the cost, or rather, should I say, the risk, or the hypothetical cost that we could incur. Okay? Potentially this is that, or close to really regular that. The hypothetical cost that we could incur by coupling to a particular thing. So, I'm Chris. I'd be delighted to hear what you think. If you disagree, if you agree, if you would like to add, if you would like to put terms on the thing to the thing I'm saying. So, thanks for having this chat with me, and I'll see you next time.